The topic for today is to interpret two-way frequency tables. In the example 1, we need to construct a two-way frequency table. And we have one important question. Which type of textbook do you prefer? Okay, we can read the exercise. Jensen asked 100 people at his school whether they prefer digital or print textbooks. Construct a two-way frequency table that shows the relationship between the person's position and their textbook preference. Okay. So what we have in the first part, we need to construct the two-way frequency table using the facts that you have in the on the table on the top of the page. Which type of book do you prefer, digital books or printed books? And we have other two categories for the dividing the students and the teachers, okay? So in digital, we have 42. Printed books, we have 28. This is the preference for the students. 42 prefer digital books and 28 prefer 28, okay? 42 and 28 printed. For the teachers, we have that only 6 prefer the books in digital and 24 prefer the books printed. I think that I'm on this 24 because I prefer print. Working digital, it's complicated sometimes. Okay. For the teachers and students, you can, okay, organize this into categories. In the information you have at the right part, you can see a little chart with information. These data are categorical data. Categorical data consist of data that fall into categories. They do not have an inherent order like numerical data. Okay, we are talking about categorical data because we are dividing our data into categories. In this case, we have two categories. For the teachers or for the students, the first category is for the people, okay? The people that is on this school. And for the other category, we have what type of book they prefer, if the digital or the printed book. So you can see, I'm not going to show this because we're going to do it on the other part, so only this. And I'm going to complete this with the facts I already have on the table, okay? Continue then with this, writing the information we need. How many teachers prefer the digital books? Only 6. How many students prefer the digital books? Look that I'm watching on the rows and in the columns, okay? So how many students prefer the digital? They are 42.
42.
And in the same for the other part. How many students prefer the printed book? 28. And how many teachers prefer the printed book? They are 24, okay? Students, they are in the other part. Teachers that prefer the printed book, they are 24. We write it in the other, this is 28, okay. And the important in here, we are going to find the sum for all the rows and for the columns, okay? And you are going to see that the answer, the final answer is going to be the number of people that they ask, okay? 42 plus 6 is 48 in this case. 24 plus 28 is 52, okay? And I'm going to find the total for the vertical part too. 6 plus 24 is 30. And 42 plus 28 is 70. So when we add 30 plus 70 is 100. And 48 plus 52 is 100. So you can see even if you add this or if you add the other category, you need to obtain the same result. Because this is the original data that you have. They told you that they asked the same questions to 100 people. So the total of the people has to be 100, okay? It couldn't be another number. Now you can see that we can represent the same categories, the same two categories, but only in different order. Now I'm writing on the top the type of book we have. If the book is in digital or printed, and in the rows, I'm writing the people who uses these books, if they are students of or they are teachers. And in the same way, I have to write the total at the end. So how many students prefer the digital books? We have it in here. You can see that this has the form of the same of the first table, only that in the first table, I didn't write the total. We don't have the total, okay? So we need to do again the table only to have it complete. But we can complete with the facts that we already have. 48, 42, and 28. So 42 students prefer the digital books and 28 students prefer the printed book. You can see that I locate using the rows and the columns, okay? And how many teachers prefer the digital books? 6. And how many teachers prefer the printed book? 24. We have the data for the students, for the teachers, and the books they prefer. And now I obtain the addition of these quantities, okay? 42 plus 28 is going to be 70. 6 plus 24 is going to be 30. Since the moment you add this 70 plus 30, you obtain 100. And you can prove it if you add this. 42 plus 6 is 48, and 28 plus 24 is 52. If you add these two numbers, you are going to obtain 102. The addition of the sum of this has to be the same addition of this, okay? Because it's the same total. Okay. Then we are going to interpret the data that we already have. For the first one, the column category is people at the school, students or teachers. And in the other part, the row category, okay, the lines we have in here, is textbooks. If the textbook is digital or print. Then for the other, we have the same information, only that in the different order. In the category for the columns, we have if the book is digital or printed. And in the row, we have the students or the teachers, okay? But you can see that is exactly the same. That's the reason why this is called a two-way frequency table, because we can order this in two different ways, okay? And it's a frequency table, okay? We are going to obtain the same result in here. The order of the categories doesn't matter here, since these are not numerical. These are not numbers, these are the categories. So you write it in words, and what you need to be attentive is with the numbers that you write inside each category, because remember, then you need to add to find the total for each one, okay? So for example, you can see that in digital, the total for the digital books is 48. The total for the printed books is 52. The total of the teachers, they are 30. The total of the students, they are 70. You can see in each row and in each column, I'm obtaining the total for each part, okay? That for you to understand how to interpret the tables, okay? The tables with the information. On the example 2, we need only to interpret. We don't need to construct they already give us the table, so we only need to interpret the data that we obtain. Example 2, the two-way frequency table shows the results of a media survey. People respond to the question, do you spend more time watching the winter or the summer Olympic Games on television? Decide if the following statement is true or false. Explain. The statement is that more men than women spend more time watching the Winter Olympics. So the information we have, it's two categories. The first one is for the winter or the summer, the Olympic Games, and the other is for the men and for the women, the people that watch this kind of programs. So for the men that watch the Olympic Games, we have 45 in winter and 34 in summer. The total of men that watch the Olympic Games, it could be winter or summer, the total is 79. Now for the number of women that watch the Winter Olympic Games, they are 27. And for the number of women that watch the Summer Olympic Games, they are 44. Then we add again and we obtain 71 women that are going to watch the games. Okay, can you see the importance in here? They already give you the table with the information, but we can use this opportunity to understand what's going on in here. You write all the data, guys, and you need to sum in each column and each row, okay? Then I'm going to add the information in here to obtain the total for this column. The total of people that watch the Winter Olympic Games, including men and women, they are 72. And the number of people that watch the Summer Games, including men and women, they are 78. So what is the total when you add 79 plus 71? Or if you add 72 plus 78, remember the result of this addition has to be the same result for this, and it's 150. I'm going to use one color to show you, maybe. Okay. For this one, okay. Then, how are we going to interpret this? They're asking you about one statement. More men than women spend more time watching the Olympic Games. How I'm going to know if the number of men or the number of women is bigger? Okay. Since the first moment, you can see that 45 men are watching the Olympic Games and only 27 are watching the Winter Game, only 27 women. The total of men is 79 and the total of women is 71. They are similar quantities. But in this case, you can see that it's a big difference that we have, including men and women that are watching the Olympic Games. But what we can do to work with this is the number of men that watch the Olympic game in winter divided by the total of men, 79. This is equal what? 0.57. If you multiply this by 100, you are going to obtain 57%, okay? And for the women, I can do the same. 27 women divided by the number of, the total number of women that we have, that is 71. And we are going to obtain 0.38. So the statement is true because 45 of 79 men watch the Winter Olympic Games, which is a greater ratio than 27 of 71. We obtain the ratio, we obtain the percent dividing, so we can compare the division that we obtain for the men and the part that we obtain for the women, okay? So in this case, 57% is greater than 38%, so we can say yes. More men watch the Winter Olympic Games, okay? More men than women. The women is only 38%, 0.38. Then this is about the example 2. We only needed to look in the winter and total columns to compare the data. Now we can go to the example 3. We need to construct and interpret a two-way frequency table. We are going to do both things, construct and interpret, okay? 200 people respond to a survey. Of those who had green eyes, 7 had blonde hair. Okay, what are the two categories we are going to have in here? We are talking about the eyes color and about the hair color. So what are the two categories I'm going to construct with the hair and with the eyes? And I'm going to divide this into other three categories because the eye color could be green or brown. So for the eyes color, we can have green eyes or we can have brown eyes. You can understand this if you read the exercise only. One of those who's had green eyes, the other one brown eyes. You don't have other color of eyes, so we have only two. And for the hair, if you read the exercise, 7 had blonde hair, 9 had brown hair, and 2 had red hair. Okay. So we need to construct the table with the information, then identify the least common combination of eye and hair color. Okay. And for the hair color, then we have the blonde, the brown, and the red. I need one more to write the total in here. And in here I write the total for this. Okay. How many people has blonde hair and green eyes? 7, right? You obtain this reading the exercise. Of those who had green eyes and 7, okay, the people who has green eyes, 7 are blonde, 9 had brown hair, and 2 had red hair. Okay, can you see the information is giving you the exercise, so you only draw the table and you are completing with the facts you have. In the other part, of those who had brown eyes, now I'm the category with the brown eyes, 76 had blonde hair, 76 had blonde hair, 89 had brown hair, 89, and 17 only had red hair. So the total for this, for example, the total of people that have green eyes, they are 18. The total of people that have brown hair and brown eyes, sorry, is 182. The total of people that have blonde hair is 83. The total of people that have brown hair is 98. The total of people that has red hair is 19, and the total for this is going to be 200. So the sum for the rows and the columns is 200. We have 200 people then that was identified in this case with green or brown hair or red hair too, green or brown eyes, and blonde, brown, or red hair. We have distinct categories, different categories. And remember that we can construct this table in the other way. Blonde, brown, red, and the total for the eye hair color in vertical, in the rows, in horizontal, sorry, in horizontal in the rows, and change the eye color to the columns, okay? So remember your homework is to complete the pages 234, 35, and 36. I'm going to finish in here with this, with the recording of this.